differently, just to save paper. All right, so here we go. Number 1 says, what's the domain? What are our 2 rules for domain, guys? We got to know this. What are the 2 rules for domain? Pardon me?
Radical and...
Yeah, if there, whatever's under the radical has to be greater than or equal to 0. And whatever's in the denominator cannot be 0. So here are our problems. What's our domain? What's our domain here? No, it isn't. Don't say 3. Guys, what's the rule? X minus 3 is greater than or equal to 0. So x has to be bigger than or equal to 3. I'm going to say this one more time and then I'm done saying it. Whatever is under the radical must be greater than or equal to 0. Write that down if you can't remember it. Say it 50,000 times so you will remember it. Look, what's this right here? It's a radical. Whatever is under the radical is greater than or equal to 0. So x has to be greater than or equal to -1. That's part of the answer. What's the other rule? The denominator cannot be 0. So some of you just say x can't be 2, and that's absolutely fine. But the work is x minus 2 cannot be 0. And you do not have to show that. You certainly don't have to show that. This is easy. That's easy. You know that. So this one has a 2-part answer. 2 parts to it. All right, what about the next one? All reals. Why is this one all reals? There's no radical and there is no denominator. Those are the 2 things that cause us problems. All right, how about this one? Okay, stop. Is there a radical in that problem? No. I don't care about the numerator unless there's a radical, right? What is the only part of this problem that I care about? Denominator. So x cannot be -6. When the question involves domain, you zero in on 2 things. What are the 2 things that you hone in on? A radical and a denominator. You don't look at anything else, none of the rest of it matters. A radical and a denominator when the question is domain. All right, next, number 2. What are the implicit functions? Now this is what we did, not yesterday, but the last Monday. Implicit functions. Anybody remember what we have to do? We haven't looked at them since then. Y by itself, we got to get y equals. We're going to come up with 2 equations, remember? So here we go. Let's get y equals. So I'm going to do some changing around here. I think I'm going to add y over to this side and subtract 9. So now I have y by itself. Now how you do that is up to you. You can rearrange this any way you want, but you got to get the y squared by itself. So I just move stuff around. So now I have my y squared by itself. Now what do I do? Once I get the y by itself, now I square root. And what do I have to remember to do? When you take the actual test, there's going to be 2 answer blanks for this question. Yes. So you're going to, when you take the square root, in one answer blank, you are going to write y equals the square root of x squared minus 9. And in the other one, you're going to write negative square root x squared minus 9. Because when you take the square root, you plus or minus. The square root of y squared is just y. That's what you wanted. And then one of them is the positive and one of them is the negative. Now listen to me. These two will look exactly the same. Always. Except one will have a negative in front of it. When you square root, nothing simplifies. Don't think you can take the square root of these. You can't because of the minus. So after you square root and you've got one positive and one negative, stop. Because anything else you do is going to be wrong. So don't do anything else. Take the square root. One's positive, one's negative. They're exactly the same. Done. Next problem. Find the wholes, asymptotes for all of these. Okay. Alright, so first of all, let's pause for a second. Where do wholes come from? How do I get them? What? We have to cancel, right? We have to cancel. So if you can't cancel, and I am looking at the first problem here, nothing cancels. Don't even think about trying to cancel those x's. In order to cancel, you're going to factor something and have parentheses that are exactly the same. You're not ever going to be canceling pieces of this out. That will never work. Don't ever do it. If you're going to cancel, you're going to have this situation. Okay? So this problem has no holes. I can see that right off the bat. So no holes for this one. Now, where do vertical asymptotes come from? Verticals. Where do I look to get those? Mary Kate?
The x's?
That actually is the horizontal.
And the denominator.
To get the horizontal asymptote, we box things in.
Yeah.
So if I were to box in my x's, my horizontal asymptote would be y equals 3, because it's 3x over 1x. So horizontals come from boxing in. Where do verticals come from? Denominator. So my vertical is -1. If we were doing domain, wouldn't you tell me x can't be -1? Whatever x cannot be, that is your vertical asymptote. So when you say x can't be -1, which is correct, that means your vertical asymptote is at -1. Your picture is broken there. All right, so that one's done. B. Now, what? Yeah, nothing's going to cancel yet, but I can factor my numerator, right? So I'm going to go ahead and factor my numerator. Now, still nothing cancels, but at least something might in this situation, because it might be possible that I could cancel, but it didn't happen here. If that top had been x squared minus 25, then I would have been able to cancel, but I can't. Which means, once again, there are no holes. Because the only way to get a hole is to cancel. Now, is there anything x cannot be? Is there a vertical asymptote? -5. And when we write that down, we're going to say x equals. We're not just going to put -5. We're going to say x equals -5. Now, how do I get my horizontal asymptotes? I box them in, right? Oops, we have a little bit of a problem. Because when I box them in, it has to be x over x, or x squared over x squared. I can't be mixing them. So do you remember how I handle that? I put a 0. I need, this is a 1x squared, so I've got 0x squared. Now I can box. We always box the biggest power, the biggest, always the biggest power. So now I have 1 over 0. What about 1 over 0? Undefined. So there is no horizontal asymptote. You cannot have 1 over 0 or anything over 0. All right, one more of those. This is a bigger problem. What do you suggest we should do here to get started?
Factor the top.
Factor the top. And might as well do the bottom too while we're at it. We gotta factor everything. What can I do to factor the top? Take out a 3. Very good. Always look for that GCF. So if I take out a 3, then I can see the difference of squares. So now the top is completely factored. I took out my 3, and then I factored x squared minus 9. What about the bottom? It is going to factor.
X minus 1.
X minus 3, x minus 1. Is that what I heard back there, I hope? Uh-oh, what do you notice? Now we have some canceling, which means, guys, we're going to have a hole. This is the only way we can ever have a hole. Well, now we have one. The hole is a point. When you graph it, it's going to be an open circle in your picture, so it has coordinates. The x coordinate comes right from what you cancel. So the x coordinate is going to be 3. That's what you canceled out. 3 minus 3 is 0. That's what you canceled out. How do we find the y? Do you remember? No, we come right over here. This is our new problem, right? And we put in 3 for x. That's the x coordinate. Put it in. So we have 3 times 6 over 2. If I put in 3 here and 3 here, 3 plus 3 is 6. That's 18 over 2, that's 9. So your hole is at the point 3, 9. Where do holes come from? When you cancel. The x comes right from what canceled out. And the y comes from taking that x and plugging it back in to your reduced problem. Okay? All right. Now, what about asymptotes? Look at this now. This is our problem now. Is there anything x cannot be? 1. So your vertical asymptote is 1. Straight from the denominator. Now, how do we get horizontals? We box them in. So you can do it here. If we box in our x's, that would be 3x over x. So our horizontal asymptote is y equals 3. Some people like to box it in the original problem, and that's okay. Would I still get 3 if I did it in the original? Doesn't matter. With horizontal. With vertical and holes, you got to come all the way to here, but horizontal you can do from the beginning. Okay? All right, now we got a bunch of sketching to do. Some of them are quick little sketches and some are gonna take a little more work. So that first one is a piecewise. Sign out. So here we go with our piecewise function. All right, so remember how we do this. We do one piece at a time. These are a little bit complicated. So I'm going to start by graphing this right here. So y equals 2x plus 1. What shape is that? Y equals 2x plus 1, y equals mx plus b. What is that? That's a line, right? And it's a line that has a y-intercept at 1 and a slope of up 2 over 1. So up 2 over 1, up 2 over 1. So here is the line. It's supposed to be a nice straight line. Now, I don't want the whole line though. Remember, these are the ones we have to erase part out because we only want pieces of it. This picture is broken where x is 2. So there's where x is 2. Notice that my purple line crosses that right there. Will that be an open or closed dot?
Open.
Open, because of this right here, right? Now, I've divided this thing up into 2 pieces. This piece and that piece. One piece I keep, one piece I throw away. Erase. Remember, this tells me what to keep. So which side do I keep? The right side, right? Which is this piece right here, which means I erase all of that. This tells me which piece of my picture I keep. This also tells me where the division is, where the break is. All right, what's this shape now? I'm ready to do the second shape. What's that one?
Absolute value.
Absolute value. Value V, right? That's just going to be a V. There it is. It crosses right here, right? Open or closed dot? Look right here. That'd be a closed dot, right? For this function, that's a closed dot. And then which side am I keeping? I'm keeping that side, which means I'm going to erase this side. Remember, when you're done with the problem, you should have dots, open and closed, lined up on top of each other. Never 2 closed, never 2 opens, open and closed lined up on top of each other. Okay? Also, you should have, if the red is on the left, the purple is on the right. You should never have both colors on the left or both colors on the right. You're going to have one of each because these arrows are pointing opposite ways. Right? One of them's right, one of them's left. Anyway, that's your picture. That's it. You're done. That was easy. Now, the next ones aren't nearly as complicated. Quick little sketches for that one, and this one, and then the next one's 2, but we'll do these 2 first. All right? So tell me about this shape. What is this shape going to be? Mary Kate? A V. But If it looked like this, just the plain function, it would be V'ing out from the origin. This has this -3 inside the absolute value, so it's going to V out from where? From +3. Remember, that moves right. So on your paper, you're just going to draw your V and label this point 3, 0. It doesn't have to be any fancier than that. Just a V. I'm going to do this one over here. All right, now we have our sine function. Okay, so we got to remember first of all what the sine looks like. The sine is a little bit tricky. So we got to remember what it looks like. Starts at the origin, goes through the origin. Yep. So I'm going to go ahead and draw in a dashed line. This is my original. Now, does anybody remember how far up and down it goes? 1. Very good. So now we're going to take that thing right there, and what are we going to do with it? What does this -1 on the end tell you to do? Down. So you're going to take this picture and move everything down 1. So you can do it point by point. I don't care how you do it. So this is 0, so it's coming down here. This is coming down here. Every point is coming down 1 unit. So we have exactly the same shape, right? But everything is down 1. So the purple is the actual answer to the question. We dropped it all down 1. No, because it was its highest point was 1, Caroline.
Okay.
So if we drop it down, now the highest point is 0.
Okay.
All right, so there's a few more little quick sketches to do. These are easy if you remember your shapes. What shape is D going to be? It's a squaring, which means it's what shape? A U, a parabola. And most parabolas, the normal parabola, starts at the origin, right? This one's been moved twice. What does this do? Left 1 and down 2. So left 1 and down 2, you have your U, not upside down or anything weird like that. It's just shifted 1 unit to the left and 2 units down. This goes left, this goes down.
You guys know that Mrs. Ford is an awesome water ski. You guys know that? She can ski like crazy, this woman.
It'd be a nice morning for skiing this morning,
It would.
Mrs. Mills.
It's a perfect temperature for you.
Just one other question.
Yep.
How come we don't change the 2 to a positive?
Just don't. Vertical translations, minus means down.
Okay, so we just change one of the things.
Yep. Yep. Okay. All right, what about this one now? We all know what that shape is, right? So I'm going to just dash that in here. We don't do our cubing that often, so that would be the cubing function. Going, it kind of squiggles through the origin. The origin is like its squiggling point. Okay? Now what is that going to do to the picture? Move it up 1. So you're going to have that same picture, but now your squiggle point is up here, right? So that's going to look like that. So the red one is your answer. It squiggles up 1 from where it normally does. Okay, and one more of those. get this test done. So this is a square root function, which everybody knows that shape or should know. That's this shape, right? Dot at the origin shooting out. But now we're not going to be at the origin, are we? Where are we going to be? Over 3 and up 2. So there's our shape, but we're starting at the point 3 comma 2. All right, very, very fast. Most of those are pretty quick to do. All right, now we got our functions. This is what we just started talking about yesterday and finished today. Easy stuff. A says add f of 2 and g of negative 3. All right. All right, what does f of 2 mean? Put 2 into f. Well, yeah, into x and f. Now be careful, when you put 2 in there, you're going to get 2 times 2 squared plus 1. What do I do first here? Square. So this is going to be 2 times 4 plus 1, which is 9. So f of 2 is 9. Now g of negative 3. That'll be 3 times negative 3 minus 4. So negative 9 minus 4, negative 13. And I'm adding those according to the problem. I'm adding them. So the answer would be negative 4. Now there is a lot of room in there for arithmetic errors. Please be careful. Make sure here especially, you square first, then multiply. All right, B says, what's f of x minus g of x? Please don't overcomplicate this. What's f of x? 2x squared plus 1. And we're subtracting g of x. So we have 2x squared plus 1 minus 3x plus 4. Remember, you have to distribute the negative. Do you have any like terms in there?
4 and 1.
Yeah. So it would be 2x squared minus 3x plus 5.
That's it, right?
That's it. Stop right there. Don't do anything else. You're done. C is literally what we just talked about a few minutes ago. We have to take, well, you tell me, how do I start this? F of g of 3. What do I do first? Put 3 into g. So I'm going to put 3 into g. What do I get when I put 3 into function g? 5? 5? So then I take the 5 and put it into f. So again, watch your arithmetic. It's 2 5 squared plus 1. That's 2 times 25 plus 1. That's the order we do that. Do not multiply 2 times 5. It's 5 squared. So what is that, 51? So the answer is 51. And then the last one, we're finding g of f of x, which simply means take whatever f is, this is f, and plug it into g. So take that f and plug it into g. So we'll have 3, 2x squared plus 1 minus 4. Take whatever f, I got it in a circle right here, plug that into g, and simplify. Did you get 6x squared minus 1? Perfect. That is the entire test. That's the whole thing. Okay? So tomorrow, we will do the next one. And then, what's tomorrow, Wednesday? I don't see you on Thursday, so Friday we'll do the third one. And your test will be Tuesday, a week from today. So,